This video that we're going to produce today is about elasticity. I'm very happy to do that because the way that it's handled in the textbooks is not very instructive in my opinion. So before I do graphs and draw stuff on the board, let's talk about what elasticity is. Elasticity is a measure of the responsiveness on the part of the public to price changes. So if you walk in the store and you see price, that's not elasticity. If the price changes, that's elasticity. And if you have a response to the price, then that is a measure of the elasticity. If you have no response whatsoever, you buy the same amount, that's a special name, and we'll discuss that shortly. So again, price elasticity is a measure of response on the part of the public to price changes. Now, one of the things I don't talk about in the book too much is how many kinds of elasticity are there? The answer is infinite. Because if you change income, it's called income elasticity. If you change the gender composition of your society, going from more male and less female, that'd be sex or gender elasticity. If you talked about a population changes, that could be population elasticity. So elasticity its name is dependent upon what is under the dictum. So let's do that. Demand elasticity is the same thing as price elasticity, and it's equal to the percentage change in quantity divided by the percentage change in price. Now notice elasticity is a measure of two ratios. So don't become confused by its relationship to slope. Now I like to teach elasticity as cause and effect, which I've alluded to a moment ago. Even though I wrote percentage change in Q first and then percentage change in P, that is not particularly the way you should think about it. This is what causes you to change how much you buy. Percentage change in price is the cause, and the number on top is the effect. So, once we measure these, we find by definition that elasticity falls into three possible categories. The elasticity of demand is greater than 1. By definition, is said to be elastic. The elasticity of demand is less than 1. It's inelastic. If the elasticity of demand is equal to 1, that's considered to be unitary. While it's always useful to use flashcards and memorize definitions, that's not nearly as useful as understanding the idea they're trying to impute by giving those numerical values. Let me give an example. It would be very, very helpful if I knew when I raised prices 10%, if it was elastic, inelastic, or unitary. If it were elastic, I know that this number on top would have to be greater than 10%. And how do I know that? Is because this value is greater than 1. And therefore, the number on top has to be greater than 10%, which is the cause, and this is the effect. Let's talk about it metaphorically in terms of the physical world. If you apply a force, physical force, vector force, and rubber band, and it's elastic, then it moves a lot. Right? Same thing is true here. A lot is defined to be its comparison to the cause. Let's do another one. Let's say it's inelastic. Then, if I raise the price 10%, then we know the effect will be less than 10%, and we also know that the effect will be in a downward direction. Trying to continue on the systematic kind of analysis, if this goes up 10%, we know this has to go down by more than 10%. You'll see then that under the demand or price elasticity, that the value of this equation will have to be always negative. If this is positive, it goes down in value. If it goes down in value, this goes up in value. So the natural value of demand to price elasticity is always negative, and that's why I tell you, do not do what the book says. Do not take the absolute value. You want to multiply this by a -1. And the reason is, if you take the absolute value, you're going to not appreciate or understand cases where, as the price goes up, and it's a demand curve, you actually buy more, a Giffen good case. And the reason that you buy more when the price goes up is because you're buying not only the good, you're buying the exclusivity of the price tag. If I go to Walmart, do I take my tag out and show you that I bought my shirt at Walmart? No. But if you bought at these other stores, which are, I can't even think of the names, but they're exclusive, you might do that. So there are cases where this has a positive value, and you want to know that. You can discover that by multiplying by a -1. Let's take the special case of unitary elasticity. We say that no matter what the number is on bottom, or 10% increase, the number on top has to be what? Opposite in sign, but equal in value. Right? So if this goes down 28%, this has to go up 20% because it's always equal to 1. This has special implications for total revenue. Let's say that this is $10, and at $10, we're going to sell 1. At $5, I would tell you under unitary elasticity, this would be 2. And if this were $2 here, then we would sell not 3, not 4, but we would sell 5. What is in common with all of these graphs? What's common is that they all have the same total revenue. P times Q is equal to total revenue. P times Q is equal to a constant under unitary elastic situation. Therefore, total revenue is equal to a constant. And let me show you that by drawing the special curve that connects the upper right-hand corners of each of these rectangles. So I draw this here, and then I come around here. And what I've drawn, it's what's known as a rectangular hyperbole. And that sort of complex name there is simply a rectangle whose subtended, a hyperbola whose subtended rectangles all have equal area. 10 times 1 is $10. For the first case, 5 times 2 is $10 also, and 2 times 5 is also $10. Is there a case where this occurs? No. But we say in the contract negotiations for unions that the elasticity of demand for the product that they're selling tends to be in and around 1, so it tends to be unitary. If it happens to be actually 1, that would be an unusual case, but there's a name for it when it approaches that value. So in terms of problem solving, if you did research and you knew what the elasticity value was for the items that you're selling, I knew what the number was, and I was going to change my price, what would I know? And the answer is I would know the exact amount of sales that would take place. If I lowered my price, I would know how much more I would sell. If I raised my price, I would know in advance how my sales volume would decline. Now, as a practicing economist, I want you to know it's not nearly this simple. The only thing I would offer you as a caveat, aside from understanding the principle, is that these numbers do have value, but in and around small intervals. If you changed it drastically, then these calculations would not be very credible.